Okay, let's have a look at homework 13, proof with predicates. Now, I'm going to do something a little strange. I'm going to start with the fourth question. The reason being that this is actually probably the easiest one. So why is it question 4? Good question. I have no good answer for you. Well, I guess my answer is that it requires something a little unusual, because the way I've always said is that there are 3 stages to most proofs in predicate logic. The first stage is you instantiate to get rid of the quantifiers, then you do a regular proof, and then you generalize to get the quantifier back. But this one, you can't instantiate here, because obviously there are no quantifiers, and you can't instantiate on lines 1 or 2 either, because the main connective in both of them is the conditional. You can't instantiate that one, obviously, because it's not on the far left, and even these on the far left, they're not the main connective of the entire line, so you can't instantiate at all. So you literally cannot instantiate anywhere in lines 1, 2, and 3 here. But what you can do is, once you have simplified each of these, you can generalize them, and there's a point to doing that, because if you notice, this is L, and this is L, and this is J, and this is J. And then when you generalize them, you can do modus ponens. And once you've done modus ponens, you will get these things, and you want to instantiate them in the right order, do a conjunction, and then generalize. And that one is really very straightforward and takes probably the fewest steps of any of the proofs. So if you're feeling disheartened, if you haven't tried this one, try this one. It's probably the easiest. Next easiest is probably question 2. This one, you can instantiate line 1. You can't instantiate line 2. So you might say to yourself, well, let's do what I can do, which is instantiate line 1. Probably you shouldn't do that, because, in fact, more than probably, because although you cannot instantiate line 2 as it is, if you do the magic hopping quantifier, magic hopping tilde, you will then have something where the quantifier is the main connective, and you can instantiate that. But notice, because it's a magic hopping tilde, this will have changed to an existential. And remember the rule of thumb, you should always instantiate existentials first. So do that, and then you will have the negation. When you finally instantiate and get rid of this quantifier, you will have the negation of a conditional. Remember my trick with the negation of a conditional: if you do implication to it, it will be, because you know that not if PA then RA is true, that will be true because PA is true and RA is false. So you know that if you do implication to the negation of a conditional, you get the antecedent and the negation of the consequent. And both of those are going to be useful, as you'll see. The first of those is going to be useful pretty quickly once you instantiate this. The other thing to remember is, of course, you are not going to need the name U, even though there's a universal quantifier in the conclusion, because of this tilde. You can't, so in other words, you're not trying to get if QU and then universally, not QU and then universally generalized, because that will give you that, which is not the same as this. You would have to hop the quantifier and hop the quantifier with the tilde, and that would have the effect of changing that. So it's the same thing as actually we talked about in class with this one. You're not going to need U for that one either. So this one is also a fairly quick proof. This takes the most number of steps, but it's not the hardest. The hardest is question 3, and we'll get to that in a second. I talked about this a fair amount in class. because you can't instantiate line 1, you're going to have to do modus tollens on line 1. And to do modus tollens, you need the negation of the consequent. So you're going to have to try and get this. And in order to get that, you're going to arrive at that by quantifying negation. So of course you're going to have to get this. And in order to get this, you're going to have to get this first, so that you can do universal generalization to get that, and then quantifier negation to get that. So you're going to try and get this, and you're going to get it out of line 2. Another thing to notice, though, is that when you do modus tollens, you're going to end up with this with a tilde in the front of it, and you cannot instantiate that until you hop the tilde, and when you hop the tilde you will have an existential, so you cannot use u. You're going to have to use another new name, and that's going to be the name that you end up generalizing from here. Okay, I hope that makes sense. So you will have to actually instantiate twice, once to get the name u out of this one, and then again to get the name, whatever name you use with this one, which is going to be, say, a. And you might have to instantiate, you're going to have to instantiate again to get something out of this one with an a in it. Now, all of that in the abstract probably doesn't make much sense, but if you try and do it, it should make more sense. Okay. Question 3. Alright, with question 3, as we said, the end game is to get this and do a hypothetical syllogism. So you want to have GU then HU and HU then EU. You want to somehow get those. Then you're going to do hypothetical syllogism, and you're going to get if GU then EU, and then you're going to generalize from that to get this, to get the conclusion. So because the conclusion does have a universal quantifier, that's why you're going to need the name U. Alright, getting this one is going to be easy. You can just instantiate. It's getting this one that's going to be slightly harder. In order to do that, you need to do modus ponens, and you need to somehow get this. Okay, how are you going to get that? Well, you need to get EA and existentially generalize to get that. How are you going to get this? The answer is you're going to get it out of these two. So you're actually going to instantiate this one first, then you're going to instantiate this one to match it, and later on you're going to instantiate again from this to get the U. So you're going to instantiate from this one, from line 3, twice. First to match whatever name you use here, which can't be U because it's going to be introduced by an existential, and then later with a U. Alright, I've already said that there are two ways to get EA out of this. One way is to, first of all, instantiate with a name. So let's say on line 4 you get EA or HA by existential instantiation, line 2, and then you can instantiate from line 3 to match the name. I'll let you fill that one in, and one of two things will get you this. Either you'll just keep going without assuming, and you will probably need to do some, it will probably involve imp, hypothetical syllogism, and imp again, and tautology. Or, if you were slightly more adventurous, you can, on line 6, assume not EA by assumption reductio ad absurdum, and go on until you get a contradiction. which I'm going to guess is HA and not HA, or it could be EA and not EA. And then you go back out, say on line 13 or something, and you will have EA by reductio ad absurdum. This would be line 12, 6 through 12, and then you can get on with what you were doing. You can generalize that, you can do modus ponens. Okay, so those are two possible ways, and that's the hardest one, although not the one with the most number of steps. The most number of steps is probably question 1. That will need about 18 lines in total. The rest of them are around 13 to 15 will be the number of lines you will need total. Alright, hope that helps. I will try and get in on Wednesday between 10 and 12.